Okay, so a couple of other things I wanted to point out. Make sure you're practicing going over which muscles are responsible for respiration. So you've got quiet breathing, and that's mainly going to be your diaphragm, which is your major MVP, and then your external intercostal. Then you need to know your accessory muscles of inspiration, which are going to be involved in forceful inspiration. So all of those in your tag list are the ones you need to know: internal intercostal muscles, pectoralis minor muscles, sternocleidoid muscle, scalene muscle, serratus anterior muscles. And basically I would, in erector spinae, and basically I would just remember that these muscles help you forcefully inspire by elevating the ribs. Whereas your accessory muscles of expiration are going to help you with forceful breathing out, and that's going to include your internal intercostal muscles, your rectus abdominis, external oblique muscle, internal oblique muscle, and transverse abdominis muscle, and all of those are going to help you depress that thoracic cage. It's going to help you sort of depress and compress. So I highly recommend you look through some of the pictures that I send you and try labeling these muscles of respiration for yourself and identifying them. So someone asked me in lab where the maxillary sinuses were, and it was hard to see on that one model we were looking at in the beginning. So I just wanted to show you right here that these are going to be your maxillary sinuses. They're just underneath these little eye sockets here. So that's where so that would be number 10 right here. Okay. And also wanted to make sure that we quickly go over our spirometry graph. So we can measure our respiratory health by an instrument called a spirometer that will measure changes in our lung volume across time. And this is called a spirometry graph. You need to know that lung volume is on this axis here. And when we're talking about quiet breathing, the changes in that is going to involve our, this is our tidal volume here. So like a tidal wave, you're going to see these little waves here. And basically, it's the amount of air that you're taking in as well as expelling out of your lungs during a quiet breath. So this volume from the top of your tidal volume peak to your maximum is going to be your inspiratory reserve volume. So think about what a reserve means, right? So this is going to be the volume change for a forceful inspiration. Expiratory reserve volume is the volume that you would be expiring for a forceful expiration. Okay. Now, when we breathe out, even if you breathe out as forcefully as you could, even if you breathe out, with as much squeezing as you possibly can, you're really not going to be expelling all the air out of your lungs. So that is going to be our residual volume. So a major difference between volumes and capacities is these volumes are measurements that represent what's happening to the volume of air when we're going through certain types of respiration, whereas our capacities are calculations we're doing with these values. So our inspiratory capacity makes perfect sense because the inspiratory capacity represents our total ability to inspire. So if that's the total lung change in inspiring, well, you have to account for the change in the tidal volume, right? Because that's our quiet inspiration, and the change for forceful inspiration. So that's why IC, inspiratory capacity, equals IRV plus TV. Then we've got our functional residual capacity. And functional residual capacity is the amount of air that's normally left in your lungs after you expire quietly. And so remember, tidal volume is the change for quiet expiration. So at the very bottom of this curve, all the way down to completely no air in your lungs, that's your functional residual capacity. So they could ask you something like, given total lung capacity and given inspiratory capacity, find functional residual capacity. And so you can just subtract TLC minus IC to get FRC, or you can take FRC and add ERV plus RV. So expiratory reserve volume and residual volume. So that's what this means. Vital capacity is your, really it's a measure of the amount of air that your lungs can hold. It's also a measure of the strength of respiration. And your book will refer to it as the total exchangeable air. So that's going to include the air you can forcefully breathe out, quietly breathe in and out, and forcefully breathe in, quietly breathe in and out, and then forcefully breathe out here. So it's going to include all of the air that you're exchanging and is going to exclude the measurement of the air that's in your lungs that you're not exchanging. So then total lung capacity, think a little TLC. TLC, you get a little bit of everything. So total lung capacity is going to be IRV plus TV plus ERV plus RV. So it's all of these values added up. TLC is, you can also think about it like the amount of air that you're exchanging plus the non-exchangeable air. During class, I mentioned the property of lung compliance. So we talked about how the lungs should be able to both expand as well as retain its original shape when it contracts. So, not contracts, I'm sorry, when it deflates. So IRV, your inspiratory reserve volume, is really going to give you a good indication of lung compliance, because it's going to be what's the maximum that you can take in to your lungs. And your ERV, your expiratory reserve volume, is going to be a good indication of your lung and chest wall elasticity, because that's going to be how much it can really push that air out. So these are some of the things that, say, someone like a respiratory therapist might want to look at to look at the health of your respiratory system. And then last but not least, I wanted to briefly mention the pleura. So back when we talked about the different layers surrounding the heart, well, guess what? We have them for lungs too. So the lungs are inside of a pleural cavity. So very similar to the layers we talked about for the lungs, you're going to have a parietal layer, right? So that's your outer layer. And this one is going to be sticking to all the surrounding organs of your lungs, around your lungs. And then visceral layer, which is the one that's actually going to be sticking to your lungs. And in between, you're going to have that fluid that's going to provide that lubrication. So, so I would just know that this one is the one that's on lung tissue. This one's the one in the lung, closer to the organs surrounding the pleural cavity and the lungs. I would also make sure that you go and take a look at some of the structures surrounding the lungs. So you'll need to know that at the base is your diaphragm muscle, what's sitting here, and what is this notch that we talked about, what sort of structures are going to be anterior or posterior, what sort of structures are going to be superior to your lungs. So I make sure